Welcome. In this module, we will dissect a critical component of Azure's physical architecture, availability zones. We will move beyond the basic region definition to understand how availability zones provide high availability, fault tolerance, and physical isolation for your mission-critical workloads. Let's get started. To understand Azure resiliency, we must define availability zones. An availability zone is not just a logical construct. It represents physically separate data centers located within a single Azure region. Crucially, each zone is equipped with its own independent power, cooling, and networking infrastructure. This design ensures that if one zone experiences a physical issue such as a power outage or cooling failure, the other zones in that region remain unaffected and operational. This physical separation is the foundation of high availability in Azure, allowing your applications to withstand data center level failures. This block diagram illustrates the physical isolation within an Azure region. You see three distinct columns representing availability zones 1, 2, and 3. Inside each zone, there is a data center paired with its own dedicated power and cooling and networking blocks. The outer region container holds them all, visualizing how they are separate physical entities unified under one regional umbrella. When deploying to availability zones, you generally choose between two service architectures. First, we have zonal resources, where you explicitly pin a resource, such as a virtual machine or a managed disk, to a specific zone, like Zone 1. Second, we have zone-redundant resources. In this model, the Azure platform automatically replicates the resource or data across multiple zones. Services like zone-redundant storage or zone-redundant load balancers operate this way, ensuring the data path survives even if one zone fails. Understanding this distinction is vital for designing resilient applications. This flowchart helps you decide between deployment types. Starting at Azure Resource, we ask deployment type. The path to the left shows zonal resources, which are pinned to Zone 1, meaning user manages replication. The path to the right shows zone-redundant resources, which are replicated across Z1, Z2, and Z3, where Azure manages replication automatically. This highlights the trade-off between control and automation. Networking plays a key role in connecting these zones. You can deploy a zone-redundant load balancer to distribute traffic across virtual machines located in different zones. This configuration is powerful because, with zone redundancy, the load balancer's data path survives as long as at least one zone in the region remains healthy. It is important to note that this capability typically requires the standard SKU for resources like load balancers and public IP addresses, as basic SKUs do not support availability zones. Here we see a standard load balancer distributing traffic to 3 VMs, each in a different zone: VM1, VM2, and VM3. The diagram illustrates resilience. If Zone 1 failure occurs, represented by the dotted lines, traffic is automatically rerouted to the remaining healthy VMs in Zone 2 and Zone 3, maintaining application uptime. Storage strategies must also align with your zone architecture. For infrastructure as a service, managed disks are zonal resources, meaning they are created in a specific zone. Interestingly, high-performance capabilities like ultra-disk compatibility are often available only for availability zones in specific regions. For broader data protection, you can utilize zone-redundant storage, or ZRS. This service synchronously replicates your data across 3 availability zones in the region, ensuring that your data remains durable and accessible even during a zonal outage. This class diagram compares storage types. Managed disk is defined by a specific zone and supports types like Premium or Ultra. In contrast, ZRS storage is defined by being zone redundant and using synchronous replication. The arrows indicate their use cases. Managed disks attach to VM workloads, while ZRS storage is often used for broad data archival or shared access. Availability zones are a cornerstone of business continuity and disaster recovery strategies. By designing your architecture to utilize zones, you protect against local failures such as fire, cooling loss, or power outages. This level of resilience is highly recommended for mission-critical applications where downtime is not an option. In fact, Azure Advisor categorizes recommendations regarding availability zones under disaster recovery and high availability, highlighting their role in maintaining business operations during disruptions. This journey map visualizes the disaster recovery process. In normal operation, both Zone 1 and Zone 2 are active and healthy. During an incident, such as a power failure in Z1, the experience dips to critical. However, the failover trigger immediately activates. In the recovery phase, Zone 2 seamlessly handles the load, returning the system to a resilient state. Finally, let's look at deployment and migration. Not all Azure regions support availability zones, so you may need to migrate services to specific regions that do. When deploying, you must ensure your resources are compatible. For example, you must select standard tier public IPs and load balancers, as basic tiers are not zone-aware. Additionally, Azure recommends using the latest generation of virtual machines, such as the DDV5 series, to ensure better performance and higher availability during maintenance events within these zones. This state diagram outlines the deployment logic. Start by Assess Region to confirm zone support. If supported, move to Check SKUs. If a basic SKU is selected, you must transition to Upgrade SKU. Once a standard SKU is confirmed, you proceed to deploy zonal, ensuring your infrastructure is compatible with availability zone requirements. To summarize, availability zones are a vital architectural component of Azure. They provide physical isolation through independent power, cooling, and networking. This design delivers resilience against data center-level failures, ensuring your services stay online. Whether you choose to pin resources as zonal or replicate them as zone redundant, leveraging these zones allows you to build robust, high-availability solutions that meet strict service-level agreements. Thank you for watching. Our final mind map consolidates the key takeaways. The central node availability zones branches into physical isolation, detailing independent infrastructure. It connects to deployment models, showing the choice between zonal and zone redundant. Finally, the benefits branch reinforces high availability, fault tolerance, and business continuity as the primary outcomes of using this architecture.